My name is Alex Harris, and today we're going to be talking about the horizon problem. So this diagram I think is absolutely amazing. It was given by Dr. Malcolm Fairbairn of King's College London, and I think it's the best way to really understand and explain the horizon problem. So down here we have space, right over here we have time as it's going on, and then right here is a galaxy. And as we know, since the beginning of the universe, or at the Big Bang, there was the Big Bang, and then it caused us to be constantly moving. So the universe is constantly expanding now, which means that galaxies are moving. And so this may have been where it was at one point, but here is where it is now. And as we go to learn, explain, and understand these different galaxies, we have to look at them. But when we look at them, we see them right here at this point. And that's because it is moving, so we see them at the past. We can only see things as fast as the speed of light in the age of the universe. And so, if we go to look at the opposite side, we get two different points. We have point A over here, and then point B over here. And since these are on opposite sides of space, one would assume that they have different temperatures. But as we can see from our C and B, temperatures are actually really, really similar and uniform over the entire space, or the entire universe that we can see so far. And that leads us to question and ask the horizon problem. And that's saying, why is point A and point B, or why do they have the same temperature when they're on opposite sides of space? Because we know that photons are emitted at the speed of light and travel at the speed of light. So these are our photons. And that moves at c. And so since these are so far away and because the universe is expanding, point A and point B should never really have been close enough together to where they have the same temperature. And so to explain this, astronomers have discovered that point A and point B in the early universe were actually very close to each other. And that allowed them to emit their photons and create the same temperature. But then when the Big Bang happened, there was something called cosmological inflation, which basically caused point B to rocket out this way and point B to shoot out the other way, causing them to go far together. But like I said, since they were together at one point in the universe, they were able to create or exchange photons and have the same temperature. And that's why we see now point A and point B at the same temperature and kind of a uniform picture overall. And that's the solution to the horizon problem.